This second example here, we want the probability that z is less than 1.64. We are dealing with a standard normal distribution, so our mu is still 0 in the middle. Here's one standard deviation to the right. There's two standard deviations to the right. 1.64 is going to be a little bit more than halfway between those. So I'll say that this right here is 1.64. And I want the probability that z is less than that. Less than, that points to the left, shade to the left. I want the area to the left of that. So I'm again going to be using another normal CDF function, but this time this area does not end to the left. So I'm going to say that its lower bound is about negative 1,000, negative 10,000, negative 100 would probably also work, but its upper bound is 1.64. So it does not go any further right than 1.64. Its mu is still 0 and its standard deviation is still 1. So in our calculator, we will have a normal CDF, negative 1,000 as our lower bound, 1.64 as our upper bound, 0 for mu, and 1 for our standard deviation of sigma. So I have my calculator pulled up. And what we are going to do now is we're going to use our calculator to actually compute this. So I'm going to hit second vars to go to distribution. I'm going to go down to number 2 to get normal CDF. I don't want PDF, I want CDF. PDF would just give us what it is at 1.64. So in other words, if we do PDF, it just gives us the height of that one purple bar that's at 1.64. It gives us the probability that z was equal to 1.64. But we want the probability that z is less than 1.64. So we're going to do CDF because we want a cumulative distribution function. We're going to enter our lower limit. I can leave it as that, negative 1e99. And that's just, it means it has like, what, 98 zeros on it? Or you could put negative 1,000, doesn't matter, as long as you have a very negative number in there. Upper limit is a positive 164. Don't change mu and sigma. And we get a 0.94, about 0.9495 as our answer, which is the same thing that we got when we looked this up in the standard normal distribution tables. So it doesn't matter if you use your calculator and it doesn't matter if you use your tables, you should still be getting, I'm just trying to drag this up here, the same answer. There we go.